Dear all, a very good day. In today's lecture, we are going to discuss about X-ray machines and computer tomography. Okay, step by step, we will take up the topics. First, we are going to look at X-rays. What are X-rays? And then we will be looking at some properties of X-rays and its measurement unit. Then in next lecture onwards we will be looking at X-ray machines, its functioning, and how computer tomography is undertaken, and so on in the subsequent lectures. Okay, so starting on, X-rays are electromagnetic waves that have much shorter wavelength than the radio waves or visible light. Okay, so they are at a particular end of the electromagnetic spectrum. Very short wavelength. This helps them in much of the functioning which normal electromagnetic waves cannot do. Okay, they have wavelength lambda, okay, in the range of 10 to the power minus 6 to 10 to the power minus 10 centimeters. Okay, please note this is in centimeters which we have mentioned, and their frequency is 10 to the power 10 to 10 to the power 14 megahertz. Okay, now these waves have the ability to penetrate matter and depend upon their wavelength. Okay, so depending upon the wavelength, how deep they can travel inside the matter is relevant to them. Okay, now they propagate with the speed of 3 into 10 to the power 10 centimeter per second and are unaffected by electric and magnetic fields. Okay, normally they are unaffected and they have quite a good speed. Now according to quantum theory, okay, electromagnetic radiation consists of photons which are conceived as the packet of energy. Okay, so if you are going to look at the electromagnetic theory, there is a unit known as photons. Photons are the energy particles in the form of light. Okay, and they transmit light. So X-rays are also in a form of light, even though they may not be visible to us. Okay, and they are full of energy, and the energy of X-rays is quite high in fact. So if we will look at E is equal to h nu, that is equal to hc by lambda, where E is the energy, h is the Planck's constant, nu is the velocity, and it can be given by c upon lambda, that is the speed of light upon wavelength of X-rays. Okay, so again, h is the Planck's constant. Here it is taken in joule per second and its value is 6.34 into 10 to the power minus 34. Okay, then see the velocity of propagation of photons. Okay, in this case it is not the speed of light but velocity of propagation of photons. It is 3 into 10 to the power 10 centimeter per second, centimeter square per second it should be. Okay, 3 into 10 to the power 8 meter per second, so it is quite similar to our speed of light. Then there is lambda, there is nu, that is frequency of radiation, and lambda, that is the wavelength. Yeah, so this is its velocity is 3 into 10 to the power 10 centimeter per second, or 3 into 10 to the power 8 meter per second. Okay, which is almost similar to the speed of light. Lambda is the frequency of radiation, lambda is its wavelength, and nu is its frequency of radiation. Okay, this should not be in centimeter square, as I have previously mentioned. It was wrong because this is velocity, it is in centimeter per second, so please don't get confused. This is 3 into 10 to the power 10 centimeter per second, and this amounts to 3 into 10 to the power 8 meter per second, which is slightly slower than the speed of light. Okay, in X-ray the wavelength is directly dependent upon the voltage with which radiation is produced. Okay, so it will depend upon the applied voltage on which the radiation, or through which the radiation is produced. So in the future we will be looking at the method of generation of X-rays as well. Then comes properties of X-rays. There are some 5 or 6 very important properties of X-rays which help us in its utilization in different medical applications. Okay, let us look at them now. The first one is, because of the short wavelength and extremely high energy, X-rays are able to penetrate through material which readily absorb and reflect visible light. So X-rays used for radiography. Okay, so they have very high energy and very short wavelengths. This helps them to penetrate into the materials. Okay, and because our skin is very thin as compared to our bones, so X-ray can easily pass through our skins but cannot pass through our bones. Okay, and because of this, they can be used in radiographic applications. Okay, now thereafter, X-ray are absorbed when passing through matter. The absorption depends upon the density of the matter. Again, since our bones are made up of high density material in comparison to our skin, therefore they absorb the X-rays and don't allow them to pass, whereas our skins and muscles are made up of less dense material, so they easily allow their passage. That's why if we are looking at X-ray photography, which is used to check out fractures, X-ray can be easily utilized. Then X-rays produce secondary radiation in all matter through which they pass. Okay, this secondary radiation composed of scattered radiation, characteristic radiation and electrons. So if X-ray is passing through a material, it will produce secondary radiation. It means that they will be reflected and refracted, and because of this secondary radiation, especially because of the reflection of X-rays, secondary radiations are produced. Okay, then number 4, X-rays produce ionization in gases and influence the electrical properties of liquid and solids. Okay, so if X-rays are passing through a medium, they will ionize the gases in a particular form, and even they may change electrical properties of liquids and solids, because they may cause ionization in them as well. Okay, the ionization property is used for construction of radiation measuring instruments. Okay, so this property, if we will put a fixed amount of gas in a particular material, so or a fixed amount of liquid or solid, so X-ray will ionize them. And sorry, if we are then we pass a particular X-ray of known wavelength and energy, then X-ray will ionize those particles. Now depending upon the ionization content, we can use this type of instrument in measuring of different particles or different deficiencies in human body or some other things. Then X-ray produces fluorescence in certain materials to help them emit light. Now fluorescence is a phenomena that if you energize some material, then it will produce its own light, or it will emit its own light for the time period it is getting the energy. Okay, so if X-rays are also focused on a particular fluorescent material, it will allow them to produce an light emission. Okay, and this property of X-ray is used for fluoroscopic screens and intensifying screens having been constructed. Okay, having been constructed. So for screens and intensifying screens, this property can be utilized. Finally, X-ray affects photographic paper, but it affects the photographic paper in the same way as the visible light. So here there is not much difference, and because of this only we are easily able to take the X-rays of our hand and any part which is fractured. Now unit of radiation, okay, it is Rontgen, or its symbol is R. Now this unit is based on the ability of radiation to produce ionization, that is how much ionization it can produce in a particular material. 1R is the amount of radiation which will produce 2.08 into 10 to the power 9 ion pairs per cubic centimeter of air at a standard temperature and pressure. So if our X-ray is passed through a particular material, so it should produce 2 into 0.2 into 0 2.08 into 10 power minus 19 ions, ठीक है, per cubic centimeter, but it should be at standard temperature and pressure. This is all for the present lecture. In the next lecture we will be going through production of X-rays and the X-ray machine, maybe in brief, and visualization of X-ray and so on. Okay, thank you.